The sun is, of course, the dominant source of energy reaching the surface of the Earth. The total solar power, the energy per second that we get, is 174,400 terawatts. That's trillion watts. But it's not the only source of energy reaching the surface of the Earth, and if we want to do a careful accounting here, then we have to take the others into account. First of all, there's the moon. Now, you can see the moon in the sky. That means light, which originates in the sun, is reflecting off the moon and landing on the surface of the Earth. At the full moon, that's enough light that you can even read a book outside. And the new moon, of course, you get none at all. If we averaged over the month, we get about 0.22 terawatts. That's 0.2 terawatts compared to 174,000 terawatts. And as you might imagine, we can ignore that for now. The second thing is we see stars and planets in the sky. Planets reflecting more solar energy, but stars generating their own. This, however, is even less than the light of the moon. It's less than 1/10 of a terawatt. A bigger source of energy at the surface of the Earth is the tides caused by the moon. The moon's orbit around the Earth raises a bulge, and as the Earth spins underneath it, there's friction between the water and the Earth, and that dissipates about 3.3 terawatts, that's 3.3 trillion watts of energy, continuously. Now, 3.3 compared to 174,000 is still pretty small, but it's something we have to consider. There's two other larger sources of energy to the surface of the Earth that actually come up from below. One is a consequence of the fact that the interior of the Earth is very hot. When the rocks and boulders and planetesimals fell together to make the Earth, if you clap your hands, you'll know they'll start to get warm. Well, as these rocks crash into each other, they get very warm. And the center of the Earth is still something like 5,000 degrees. That heat is slowly making its way to the surface. If you've ever been down a very deep mine, you'll know it gets hotter and hotter as you go deeper and deeper into the Earth. So that's the heat of formation of the Earth that's still here 4.5 billion years later. In addition, however, the crust of the Earth, the rocks near the surface, contain a fair amount of radioactive elements. These radioactive elements are constantly undergoing a decay, which transforms them from one element to another, and in the process releases a large amount of energy. Now, since these both come up from the ground, it's a little difficult to precisely separate them into the two buckets, but we can add them together and say how much energy is reaching the surface of the Earth from below, and it's about 46 terawatts, more than 10 times the tides, more than 100 times the moon, but still 46 compared to 174,000 is pretty small. Finally, there's stuff raining in from space that crashes into the atmosphere. You see them as shooting stars, and sometimes actually makes it all the way to the ground, meteorites. This is about 5,000 tons of material per year, which sounds like a lot, but when you average it over the entire Earth, it's less than 1/100th of a terawatt and can easily be ignored. So the total of energy that comes to the surface of the Earth, from below and from above, discounting the sun, is just about 50 terawatts. And we know that number quite precisely. What's more important in this context, however, is that it doesn't change. The solar energy, as we see, changes by about 0.1% over an 11-year period. This energy from all these other sources is incredibly steady and changes by less than 0.0006%, completely negligible and therefore offering no contribution to the changing climate.